Welcome to this channel. In this particular tutorial, we would be designing a Sallenkeyfilter using the LTspice tool. For more such videos, I request you to like, share and subscribe to my channel below. Now, click on the new schematic and we get the schematic editor. Now, click on the component and from this particular library, search for LM741 and click OK. Now, in order to rotate this particular component, use Ctrl plus R, and in order to mirror, use Ctrl plus E. Now place this particular LM741 on the schematic window. Next, we have to place the capacitor. So click on capacitor and in order to rotate, use Ctrl plus R and place the capacitor accordingly as shown in this particular tutorial. So we have placed two capacitor. Now we require resistor. Click on the resistor symbol and place the resistor R1 on the schematic window and also place the resistor R2 on the schematic window as shown in this particular tutorial. In order to rotate the resistor R2, use Ctrl plus R as shown in this particular video tutorial. And next, place the resistor R3 as shown in this particular tutorial. Now click on resistor and place the fourth resistor on the schematic window and click escape. Now let us zoom out and in order to visualize this circuit, now we have to rename the capacitors and also the resistor. Before that, let us place the voltage source. So we require 3 voltage source for this particular tutorial and place this voltage source accordingly. Next, place the ground connection across the voltage source V1, V2 and V3 and also across the resistor R3. Now click on wire, connect the voltage source V3 to the capacitor C1 and then the negative terminal to the ground. Extend the wire across the voltage source V1 and extend wire across the voltage source V2 and make the ground connection for both voltage source V1 and V2. Double click on V3 and let us change the voltage source as Vin. Double click on V1 and let us change the voltage source as VDD and double click on V2. Let us change this as VSS. Now right click on voltage source VDD, define this as 9 volt and for VSS as minus 9 volt. Now click on label net and define this as VDD. Place this across the extended wire and also across the positive terminal of the power supply of 741 and click on label net and place this VSS across the extended wire and across the negative terminal of the power supply. Now let us make some changes in order to make the circuit diagram more presentable. Click on label net and place this label net VSS across the negative terminal of the power supply of 741 and connect this to the negative terminal. Now we have to extend the V input to the capacitor C1 and connect the capacitor C1 to the other terminal of capacitor C2. Now connect the capacitor C2 to the positive side of the LM741 and the resistor R1 is connected to the LM741. Now connect the negative terminal of LM741 to the resistor R3 and resistor R2, and the other end of resistor R2 is connected to the output of LM741, and the resistor R4 is connected between the capacitor C1 and C2. Next, connect the resistor R1 to resistor R3 as shown in this particular tutorial. Now click on ground and place the ground connection near the resistor R3 and click on wire and connect this particular ground to resistor R3. Now we have to define the value for this resistor and capacitor for this particular circuit diagram. So right click on the capacitor C1 and define the capacitance as 100 nanofarad and click OK. Similarly, make the changes for capacitor C2 as 100 nanofarad. Make the changes for the resistor R1 as 8 kilo ohm and for resistor R2 as 10 kilo ohm and resistor R3 as 6 kilo ohm and resistor R4 as 8 kilo ohm. Now right click on the voltage source Vn and click on advance and click on sine wave and define the DC offset as 0, define the amplitude as 1, define the frequency as 1 kilohertz and define the AC amplitude as 1 and click OK. Next we will do the simulation. So click on edit and click on spice analysis. So we will do the AC analysis. Click on the type of sweep as decade, number of points per decade as 100, start frequency as 10 and stop frequency as 1 kilohertz and place this on the schematic window. Now let us run this particular simulation. Before that we can save this, so click on file and click on save as and we will save this particular schematic in a particular folder as Sallenkeyfilter and click save. Now run this particular simulation and you can see, place this particular probe across the output. You can see the AC analysis for the Sallenkeyfilter. Thank you for watching this tutorial. I hope this has helped your learning purpose. I request you to like, share and subscribe my channel below.